So, this is our sheet of formulas. Obviously, if you don't know the difference between arithmetic and geometric by now, you'd have big trouble finding the right formula. Let's just talk about that for 2 seconds. 2 comma 10. Can you tell if it was arithmetic or geometric yet? No. 2 comma 10 comma 20. Can you tell if it's arithmetic or geometric now? Yep, but wait a minute. Times 5 times what? Times 5 times 2? Then we'll never give you one like that because that is not a recursive sequence. What would have to be next if I was going to multiply? 50. Because if you take this divided by this, which is 5, you'd have to times by 5 every time. This divided by this also is going to be 5. I can just say times 5 this way, and therefore it has to be times 5 next. But see, sometimes they're weird. What if I say 1 and then 1.75? Do you know what to multiply by to make that happen? Even I don't. But could I figure it out? Yeah, it's the ratio. It's this divided by that. See, I know you're thinking, didn't you just add 0.75? Nope. If this is geometric, would you please take a second and use your calculator and figure out what I multiplied by? Because that's called the common ratio, and you need that on your test. You'll have to know how to do that. A lot of people are opening up their calculator, which is smart, and you'll have one on the test. $1.75 divided by 1. I can do it this fast. What is 1.75 divided by 1? Wait a minute, dividing by 1. Isn't that just 1.75? Ah, okay. So I multiplied by 1.75 to get that. So then can you tell me what the next term is? Don't say it. Figure it out. Now, because I don't have the test in front of me and know what to round to, I just write them all. 3.0625. Raise your hand if you had the same thing. Awesome. Okay. Do you get how that was a little weird because it was hard to tell what to multiply by? All right, I'm going to give you another one that's like that. If I told you this thing's geometric, you should be able to figure out what to multiply by. Do it just like we did a second ago. And then figure out what the next term is. It's called the common ratio because it's the ratio of 6.8 to 2. And if you're really good at math, you can do that in your head. 6.8 divided by 2, that's half of 6.8, which would be 3.4. But the answer isn't 3.4, not here. 3.4 is what you multiply by. It's called the common ratio. It's also known as R in our formulas. Okay? And then if you actually multiply by that, you'd get 23.12. Raise your hand if you had that one right. Okay, cool. All right. Was that arithmetic or geometric? Geometric. Since it's geometric, in our list of formulas, there's one of these that would be the right thing to use if I said, hey, can you tell me the 5th term? Well, it's one of these 3. And this one you have never used before. I'm going to teach you today, but later. So that's not it. If I want the 5th term, use your lasso. You've got a little lasso. You can copy the formula and then paste it in again. Use the lasso. Copy the right formula for u sub 5. U sub 5. You bring over the little formula for geometric and the U formula, and it says U1. And that just puts R right here. I hope you know that means times R to the n minus 1. And I know what U sub 1 is. That's right on the screen. And I know what R is. It's right on the screen. And I can do n minus 1 in my head if I know what n is. But seriously, there's at least 5 kids in here that have no idea what n is. N is for nickels.
Oh, sorry.
I bet you can figure out what n is. What is it?
N is 4.
But you did n minus 1. Just n. Just n.
Oh, it's 5.
N is 5. There you go. N is 5. That's where you find n. So you put a 5 here. U sub 1 is this guy. So you put a 2 there. You put these in parentheses. Why do parentheses matter? First hour, I messed up a problem twice. Both times because I didn't put parentheses. I'm telling you, I know some of you are getting away with it on certain problems, so you think, oh, those parentheses aren't important. Around every variable, you should put parentheses. Sometimes you'll get away with it. Sometimes you won't. If you put exactly that in your calculator, you'd be kind of dumb. Because 5 minus 4 could be done in your head. And why waste the calculator? And you might mess it up, because if you don't keep that all in the power, that'd be kind of dumb. Do the 5 minus 1 in your head and say, oh, that's 4. Then I do the rest in the calculator. I would not do it in your head, because you might think you should do 2 times 3.4 first, and you shouldn't. If you type exactly this in your calculator, what will the calculator do first? The exponent. All right. Get that final answer. It's fairly big. And get it on your calculator. And I'm going to ask you in a moment. I'm going to walk through and see it on your calculator. Because I know by this point some of you guys aren't actually typing them in your calculator yet. And it's seriously half the test is, can you type it in the calculator right? So if you're not practicing that kind, oh my gosh, you're going to be failing the test. When is the test? It's on Friday. One more side note. I'm going to be gone tomorrow. And so instead of, my life would have been so much easier if I would have just picked the video that I've made in the past, posted it for you. But I'm going to teach it today, because I think that's better for you than just playing a video tomorrow. Because if I just play the video tomorrow, you're not going to be able to pay attention. And then you'll get a huge work day tomorrow, because I'm going to teach you this stuff today. All right, but please type the sucker into your calculator and show me what it says on the screen. It's a huge number. If I asked you to read it to me, it'd be so big that you wouldn't want to read it anyways. Nice. Nice. Correct. Yep. Okay, when the first 10 kids in a row have it right, I think we've got on to something. Bella, would you read me the answer? 2.6.
267.2672.
Nice. Isn't this is kind of weird? It's a repeating number. Did you guys notice that? 2672672, and then it probably would keep going. All right. So on the test, we would tell you what to round to. All right. So that is a typical question where we asked you to find U sub 5. What if I asked you to find S sub 5? That would not be the 5th term. That would be adding up 5 terms. Now, let's go back to this thing, and remember our first term is 2, and our R is 3.4. That's all we really got to remember is it starts with 2, and the R is 3.4. And we're going to find S sub 5. That's this formula with a 5 for N. Oh, yeah, N is 5, I guess. N is 5. U sub 1, what was that again? 2. And then what was R? Because that's in 2 spots. It's here and here, and notice me putting parentheses for it. What was our R again? 3 point what? 3.4. Last hour, tons of mistakes were made. Be very careful as you type it in. If I were you, I would do this in my head. Can you do 3.4 minus 1? Of course you can. 3.4, take away 1, you can do that in your head. That way you won't mess up and have to like put in all those parentheses and figure out, you know, the right order of operations and stuff. Just do it in your head. But all this I would definitely use a calculator for. And I'd put in all the parentheses. You need a parenthesis here, so there'll actually be 2 parentheses. I'm going to make the parentheses that are going around the 3.4 in green so you can see them better. All right, practice typing that puppy in. But the bottom I wouldn't type in, I would do in my head. Does your answer start with a 3? Raise your hand if it does. All right. 377.7952, but let's just round it off to about 378. Guys get an answer that would have rounded to 378? All right. Now, if you didn't, it's because you messed up the putting it in the calculator part, which I'm warning you, you got to get that straight. Okay, now let's talk about adding up things to infinity. It's this last formula you've never done before. Right there, I scribbled it off before, but yeah, you have some adding to infinity problems, and it's honestly the easiest equation that we have. Look what you need for it. You'll never change infinity, because that's infinity. It's going to be infinity, and when you do it on the test, that part never changes. You just need the first term, 1 minus r. Okay, so notice r, that's the common ratio. All right, so I'm going to give you an example of one. If I start with 20, because I'm going to stand 20 feet from the door. My best guess is that this is about 20 feet from the door. Okay? This is a mind bender I used to just use without teaching the formula at the end, because I would teach it to kids at a lower level of math than you, and I would say, if I wanted to get to that door, would you agree I have to go halfway to the door first? Right? Okay, so if I go halfway to the door, how far was it? That was 10. I said it was 20 feet to the door. Okay. So then if I really went halfway, I'm about 10 feet right there. I'm going to write a 10. Everybody write down 10. Plus, okay, if I went halfway to the door, I was 10 feet from the door. Now, don't I have to go halfway to the door again? How far will that be? No, half of the 10. I just went 5 feet. Know what I'm saying? I just added another 5 feet. 10 plus 5. So I started here at 20 feet. Then I went to 10 feet. That was halfway. And then I went to 5 feet. 5 more feet. And now I'm 5 feet away from the door. Right? But to get to the door, don't I have to go halfway again? You get what I'm saying? I'm just going to keep doing halfway, 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 halfway. And here's the part that messes with your head. Wouldn't you agree you could keep doing that infinitely many times? Halfway, 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 and you still don't get to the door. Because wouldn't it take you some amount of time to do each halfway to the door? Some amount of time to get halfway, halfway, halfway. And then if you add up infinite things, how can you get to a whole number? But we do, because if I'm 20 feet from the door, you all know that I'm going to get to the door. And it doesn't take infinite time. And yet, it's adding up an infinite set of halves. Halfway to the door, halfway to the door, halfway to the door, halfway to the door. Isn't that kind of cool that you could add up an infinite number of things? Infinite amounts of little pieces of time, but they add up to a whole number. I mean, it only takes me so long to get to the door. and yet it's an adding an infinite number of things. All right, so if this was our math problem on the test, how would we do it? Well, first of all, you grab the formula, S sub infinity equals U1 over 1 minus R. And everybody in here, if you don't know what U1 is by now, I have failed you as a teacher. U1 is the first term, it's 10. 1 minus R. Well, I did explain to you 2 seconds ago how to find R, the common ratio. You take this divided by this. 10 divided by 5 is 1/2. I'm just reducing 10 over 5. Sorry, 5 divided by 10. Sorry, 5 divided by 10. Couldn't I have put 0.5? Yeah, totally good to use decimals when they're easy like that. 10 over 1 minus 0.5. Well, what is? I can do that in my head. 1 take away 1/2 is 1/2. And from there, you can use a calculator. 10 divided by 0.5. And if the number 20 confuses you, I get it, but it's like you have 10 cookies and you're dividing it into half cookies. Now you got 20 half cookies. And the reason it was really 20 is because I started 20 feet from the door. And I went halfway. And then I went halfway. And then I went halfway and halfway. And I added them all up and it added up to 20. Which makes sense because I was 20 feet from the door. So the problem will present like this. And you'll just have to use this formula. And you might just think, if you've noticed this, can't you just double the first number? No, not every time. You could on this problem. But could you every single time? No, because sometimes R isn't a half. I'll give you an example. Let's say I started 18. No, wait, let me think. I'm just going to say the first number is 9 instead of talking about how far away I was from the door. I'm just going to say the first number is 9, and the next number is 3, and the next number is 1. At first, you might think, wait a minute, you subtracted 6, and then you subtracted 2. This doesn't make any sense. And then you realize it's not subtract. It must be one of those kind where you're multiplying by something. If you're confused of what I multiplied by, you take this divided by that. It looks like I'm multiplying by 1/3. Does that make sense to you? 1/3. 1/3 of 3. Does that make sense to you? You getting this? Okay, now my question is, what's S sub infinity? I'll save you the time. It's U1 over 1 minus R. Use your formula, figure it out. The answer is not just double the first number. That does not work. It only works if you're going halfway to something. If your R is 1/2. All right, so there's only 3 things you gotta know. The formula, somebody's got music playing so loud that we can hear it. Pausing for a second. Okay, so S sub infinity, the thing for today. Did you know what the first term was? It was 9. So you put a 9 right here. And then you put in a 1 minus an R, and the R is the common ratio, which is this thing. Was that divided by that? 3 divided by 9. 3 divided by 9 is 1/3. You can put 0.333 if you want. Don't just put 0.3 though. That wouldn't be close enough. 1/3 is 0.3 repeating. I can do this in my head because I'm good at math. Maybe you can't, but it's 0.666. It's 2/3. I know technically it's 2/3. And now I would have used a calculator at this moment. And let's see if we get the same thing.
I have a question.
Yes, go ahead.
Are you able to put 0.67 instead?
Well, how about this? I put 0.666 4 times, actually, and I got 13.5013. Now, I guarantee you, if you put 0.67, it's going to be different.
Yeah.
What did you get?
I have 13.43.
0.43. Do you get that they're close, but different?
Yeah. Well, there's someone close.
It's pretty close. I mean, 43 compared to 50. So, yeah. So, which one's more accurate?
I would say the one of 166.
Yeah. So, bottom line, you rounded a little too early. Put a bunch of 6s in. Now, if this was on the test, I would have said you rounded too early. And I would have said 13.5. If you can get that by, you probably could have had 0.66, like 2 sixes or 3 sixes, and still been better off than 0.67. All right, so don't round too much. Okay, that's adding to infinity. Let me give you one last question to make sure you really got this. Let's say I have 10 plus 2 plus, and I tell you it's geometric. I'm not subtracting 8 each time. Can you figure out by using the common ratio of two numbers what the next number would be? Just figure out the next number. That's all I'm asking. Then we'll do the sum of infinity in a second. Just figure out what's the next number. If you can't figure this out, you're in danger on this Friday test. It's not subtract 8 because it's geometric, so it's got to be multiplied by something. You've got to know what to do. Ratio means divide two numbers. You divide 2 divided by 10. 2/10. Now, if you'd use a calculator, that'd be 0.2. Who had 0.2? Raise your hand if you had 0.2. Nice. Then if you times by 0.2, and where did you get the 0.2 again? From this, which came from this divided by that. Then take 2 times 0.2, and 2 times 2 is 4, but there's a decimal in there, so it's going to be 0.4. All right, raise your hand if you had 0.4. Nice. You could keep doing that forever. Then you could figure out S sub infinity. Use the little formula. Last one. Try it. What is S sub infinity? Use the formula. You got this. Here, I'll help you with the formula. U1, 1 minus R. Damien, what's U1? Good. Anybody knows what 1 minus is? How about, what's the R? 0.2. Very good. I bet most of you could do 1 minus 0.2 in your head. It'd be 0.8, right? So then it's really 10 over 0.8. Now, I know some of you had to use a calculator for that. That's fine. What's 10 divided by 0.8? I could do it, but I'm just going to use my calculator because I don't want to make a mistake. I'm recording this one, so. Did you get 12.5? Raise your hand if you had 12.5. Nice. Now, 10 divided by 0.8 here came out to 12.5. Does it make sense that you add up all of these numbers and it would only add up to 12.5? It does. It's the fact. It's what it adds up to. It's 10 plus 2 is 12. And all the rest of the numbers, all the rest of them, all of them added up total, it's only going to be 12.5. And now it's kind of weird because the next number is 0.4. Well, it's because if you multiply by 0.2 again, you're going to get 0.08. You're adding these tiny, tiny little pieces up together, and it will come out to that for a grand total. All right, that's enough about sum to infinity. Now we're going to do the first question of that homework. So it's a Schoology quiz. Find it, open it, we'll do the first problem. And then I'm going to try to get you to pay attention for just about 5 more minutes. And I'm going to try to teach you tomorrow's stuff. But I think we should take a short break, otherwise I don't think that people pay attention. So right now, we're gonna do that first problem of the Schoology quiz. I knew it. There was a kid back there last hour who said, I didn't do it. Sitting up here. There is a worksheet. I'm gonna give you another. The worksheet is what is tomorrow's one. I'm giving it to you early, so the sub will just have some extra copies. All right, here we go. There's somebody who looks like they're sleeping. I don't want to personally embarrass them, but wake up so I don't have to personally embarrass you. All right, here we go. Nichols, would you read me number 1 of the Schoology quiz? S sub infinity, I know that.
Yep.
Of what?
It goes 3 plus 1
3
plus 1/3.
plus 1 plus 1/3. Okay. It's not just adding each time, even though there's pluses. I hate that there's pluses in there, but there is. But it's definitely not just adding something each time, so I can do it. It's got a u1 over 1 minus r formula. I know what u1 is. That's easy. It's 3. Then I guess the only other thing I got to figure out is r and put it in the calculator, and I'll get my answer. So r, you take this one divided by this one. 1/3. See? This one divided by this one. Second one divided by the first one. And 1 minus 1/3, I can do that in my head. That's 2/3. If you can't, you can use a calculator, and it would have told you 0.66666. And then it's 3 divided by that, which is, like I said, 3 divided by 0.66666. And we said before, put in a lot of sixes. You don't want to round it too early. And then take a wild guess what this rounds to. It's not too hard. Look at all those zeros. What do you think that rounds to? Seriously can't tell. Whether I rounded to the tenths, the hundredths, the thousands, or the 10,000ths, it's 4.5. So the answer is 4.5. Why is this little extra crap here? Because I didn't keep doing sixes forever. If I would have done even more sixes, 0.6666666 like a whole bunch of times, it would have eventually been so much that the calculator would have just said 4.5. But I had some left over because I didn't round exactly. All right, so there's my answer, 4.5. That's what you put in your calculator, or sorry, that's what you put in the Schoology, your first answer. Now that the rest of those problems I think aren't too bad, and you know how these work. At the end of your first try, you're going to see the answers, and if you messed them all up, I guess you get a chance to take it a second time. All right. Now here's the really hard part. I want you to just kind of rest your brain for a minute, and then I need to come back and teach you tomorrow's stuff, but I'm going to give you some work time. Just kind of chill, kind of relax your brain for a minute, and then I will need you to give me your attention again. But take like at least 5 minutes off here. I'm going to pause the video, and then I'll explain the new stuff that we're doing tomorrow. So take a break. Just a little tiny add-on. One of the questions has something like this. This kind cannot add up to infinity. Think about it for a second. If the numbers keep going up and you add them all up and they keep getting bigger every time, that can't be added. So this formula only works when the numbers are going down. So, moral of the story is this formula only works when your r is less than 1. Another way to say that is only when you're multiplying by a decimal. Because see, if they keep getting bigger, that's just going to add up to infinity. So one of your homework questions asks you, will this be able, or something like it, be able to be added up to infinity? And the answer is no. It's only when it's going down. Like it has to be like this. This kind won't work. This kind works when they're getting smaller and smaller and smaller. All right, and now I need to teach you that last thing. For this, weirdly, I need you to just turn your iPads over on your desk. You don't have to shut them completely down. Just turn them upside down, otherwise I don't trust you. Turn your iPad upside down. I know, you'd rather work on something else, but you need to learn this. Gabe, you too. Turn your iPad upside down. Just listen. This is really rare. Turn it. Bennett. Now. Wait to waste my time. Good, thank you. All right, here we go. So this is a Greek letter, and you have this in your next assignment. It is called a sigma. It's the sign for add it all up. Do you get, we've been doing a lot of that where you add it all up. Okay, so these sigma problems, they will always have an I in it, and they'll have a small number and a bigger number up here. Smaller on the bottom, bigger on the top. And then they have something like this. So if I told you that this means add it all up, and the smallest I is 1, I really wish they also put I equals 3 on the top. They don't, but you could know that this is true. It's saying if I goes between 1 and 3, add it all up. Well, if you just do one little thing at a time, it's not that bad. Take this one, stick it in, and then you'd have 2 times 1, which would be 2. Plus, then you do it again. And you say, what's next? If you're going between 1 and 3, the next thing to say is, well, I equals 2 must be in there somewhere. So you stick in a 2. And then 2 times 2 is 4. And then you keep adding them up. And then you stick in the third one. You stick in a 3. And the 3 goes here. And then it's 2 times 3 is 6. Really, this big complicated thing gave you these 3 numbers, and it just says add them up. 2 plus 4 is 6, plus 6 is 12. Adds up to 12. I'm going to do another one. Anybody have a short-term memory? What's that weird Greek letter?
Sigma.
Sigma. What's I going to be between?
2 and 5.
2 and 5. What's the smallest I that there will ever be? 2. If I said it was 4i now, what's the first thing you should figure out? Take that, stick it in there. And 8 is your first term. And you're going to add up a bunch of terms. Do you get how I got the 8? I stuck 2 in. All right. So now what's the next thing I'm going to stick in? 3. And then 4 times 3 is 12. Plus, what's the next thing I'm going to stick in?
4.
4. 4 times 4 is 16. And what's the next thing I'm going to stick in? 5. And that's the last thing you stick in. 5 times 4 is 20. Add them all up. That's called sigma notation. It's not that bad, is it? All right, let's see now. Flip your iPad back. Get a blank spot on your iPad. Try one. Don't go back to doing other things. Try one. I equals 3. And let's put a 5 up here. Copy this down. If you don't practice 1 right now, it's just going to leave your brain like it never was there. Because you only remember 10% of what you hear. You got to do 1 or it'll go away so fast. Got that copied? Now let's say I said 2i plus 5. Oh, it's so different. Oh, it's just add 5 after you times by 2. Now, it's a series of a bunch of things you're just going to add up. The first thing you do is stick this in there. Can you do it in your head? I can do it in my head. 2 times the 3 is 6, plus the 5 is 11. See how I got 11? 2 times 3 is 6, plus 5 is 11. And then you find the next term, and then the next term, and then you're done. Because after you do 3, of course you're going to do 4. Sticking in 4 in my head. 2 times 4 is 8, plus 5. 8 plus 5 is 13. And then you go stick in 5, and that's the last thing you stick in. 2 times 5 is 10 plus 5. 10 plus 5 is 15. And 11, 13, 15. That makes sense. It's like a pattern. Add them all up. My final answer, 10, 20, 30, 8, 9, 39 is what it adds up to. All right. Now, I'm going to do one of those with you because your assignment on that is, this is tomorrow's worksheet. It's one of the sides of this worksheet. I'll tell you which one once you all have it in front of you. Find the side that has sigma on it. I'm trying to hand it out in the right side up orientation. The side that has sigma on it, we'll do that first problem together. Now I put those iPads away, probably for the rest of the hour. I know you want to work on the other thing, but remember, tomorrow's a work day. I want you to work on this worksheet right now. Keep it sigma side up, please. Okay, the first problem, number 1, on the sigma side. If yours doesn't look like this, then you're not on the sigma side. First thing to do is just recognize, oh, this is a sigma. That means I'm supposed to add up a bunch of things. And the lowest I have is 1. And then it's going to keep going until I get to 6. So I got to do 1 and 2 and 3 and 4 and 5 and 6. Okay, I got to stick in 1 first. So I go stick 1 in here. And I can do it in my head really easy. 3 times 1 is 3. Plus, then what do you stick in? After sticking in 1, you're going to stick in 2. So I'm going to stick in 2. 3 times 2 is 6. Plus, and then how do I get the third one? Nichols, what do I put in next? 3. 3 times 3 is 9. Plus, and then I'm going to put in, I think you get the idea. I'm going to put in 4. And that's 12. And then I'm going to put in 5. And then 5 times 3 is 15. And then I'm going to put in 6 because it tells me that's the last one we put in. 6. 3 times the 6 is 18. And if you look at that number pattern, you can see it's just adding 3 each time. Isn't that weird? And yet we were multiplying by 3. But multiply by something and add something is kind of similar. Multiplying by 3 is like adding 3 a whole bunch of times. All right. And then I add them all up. Isn't there a faster way? Well, there is, but then I would have to go find another formula. And I think these are always going to be small enough that it's just faster to just add them. You got a calculator, just take a second and add them. The final answer is whatever they all add up to. All right. I know you can add those up later. If you've got them written down, you can add them up later. I'm going to go to number 2. This was for number 1. Number 2. Summation, sigma sign. The sigma goes from I equals 2 to 5. So I'm going to start with 2, and then I'm going to do 3 and 4 and 5. And then it's I squared minus 1. Where do you put the 2? It says I equals 2, so you put the 2 here. I can do that in my head. 2 squared is 4, minus 1 is 3. Plus, and I'm just going to keep doing that. Now I'm going to stick in 3. 3 squared is 9, minus 1 is 8. Plus, and then I'm going to stick in 4, and then I'm going to stick in 5, and then I'm going to be done. Get the idea? And then you just add them all up. All right. Now you want to, trust me, go down to number 5. We got to do one of these together. 1, 2, skip a few. We've now got to number 5. Take a look at number 5. It says 7 plus 14 plus 21 plus 28. If I was going to have to do this, I'd make a sigma. That's the point, is they want you to make a sigma for this. So you make a sigma. And at first you might be just like, I have no idea what to do. But then I hope you remember that these were always I equals. Every single time it was I equals. And then I'm going to tell you something that makes these easy. Always start with 1. You get to pick that number, so you should pick 1. I equals 1. And now think about it. How many different numbers did they add? So if I put in 1 and 2 and 3 and 4, you see what I mean? I can know to always start with I equals 1. And then however many there are, that goes there. And then the last thing is, do you remember that there's an I out here? Every single problem we had, there was an I out there because we had to stick the numbers in something. And then if you actually are going to go stick a 1 in there and you want your first answer to be 7, think about it. Can I just leave the I out there alone? No. It has to be something in front of the I. If I want the answer to be 7, 7I. That way when I stick the 1 in, it'll work. All right. Now I know, being gone tomorrow, there's going to be something that confuse you. I've released the key so that when you get stuck tomorrow and you're like, what the heck's going on? You can go look at the key, and there's some tricky ones. But you don't have to be expert at this yet. You have to be an expert by Friday. It's Monday. So we'll get better at this. All right, that's all I got for the video for today.